So we know that the motion of electrons in an electric circuit constitute an electric current. It's okay. Charge means electron, the flow of electrons. Flow of charge means flow of electrons. So electrons, however, are not completely free to move within a conductor. They are not free to move. Okay, they are restrained by the attraction of atoms among which they move. Is, conductors are made up of atoms, and so whenever the electrons move through atoms, there is a force of attraction between the atom and this electron. So they restrain, they object the movement of electron. Atoms object the movement of electrons. Thus, motion of electron through a conductor is retarded by its resistance. So a compound of a given size that offers a low resistance is a good conductor. Okay. So a compound having some appreciable resistance is called a resistor. They should have some appreciable resistance. So the compounds of identical size that offers a higher resistance is a poor conductor. Yes, an insulator is a same size offers even higher resistance. Means insulator, okay, doesn't allow current to pass through. Yes, it is observed that the ammeter reading decreases to half when the length of the wire is doubled. Yes, look here, when the length is double, the ammeter reading decreases to half. Ammeter, what does ammeter measure? Ammeter measures current, it is, so it becomes half. So when the conductor is doubled, when the length of the wire is doubled, the ammeter reading becomes half. So the ammeter reading is increased when thicker wire of the same material and the same length is used, okay, in the circuit here. Means thicker wire, okay, allows current to pass easily. So the change in ammeter reading is observed when a wire of different material of the same length and the same area cross section is used. It is here. And ammeter reading is observed when the wire of different materials of the same length and the same. On applying Ohm's law, so what do you see that the resistance of a conductor depends on the factors, the length. More the length, more is the resistance. On the basis of cross section, if the cross section is more, okay, the resistance is less. It is here. Means thicker wire has less resistance and thinner wire has more resistance. And the third is on the nature of material, is of what the conductor is made up of, whether it is made up of copper, silver, aluminum, gold, like this it is here. So that depends on also, and it also depends on the temperature. If the temperature increases, the resistance also increases. Okay. Now okay, so if you add up mathematically all these three factors, R is proportional to I, or R is proportional to I by A. I by A it is, okay. R is proportional to I by A. A is area here. A is area of the cross section. Cross section means this is the cross section. Cross section means a thick wire will have more cross section area and thin wire will have less cross section area. So if we combine these two together, R is proportional to L by A, and R is, look here, there is a proportional sign. R is proportional to L by A. R is directly proportional to the length and inversely proportional to the area. When the area is more, resistance is less. When the area is less, resistance is more. And R is directly proportional to the length. When the length is more, R is more. When length is small, R is small. Or here now R is equal to rho L by A. This is rho. This is rho. Okay, what is rho here? Okay, it is a proportionality, constant of proportionality, and is called the electrical resistivity of the material. Electrical resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. Look at this is ohm meter. This is ohm meter. Ohm meter. Resistivity has the SI unit ohm meter. Now, what is resistivity? So it is the characteristic property of material. Yes, every material have its characteristic property. Okay, and that characteristic property material or the material is known as resistivity. So the metals and the alloys have very low resistivity. Okay, the metals and alloys have very low resistivity. Okay, in the range of 10 to the power minus 8 ohm to 10 to the power minus 6 ohm meter. This is ohm meter. 10 to the power minus 8 ohm meter and 10 to the power minus 6 ohm meter. So they are good conductors of electricity. Yes, if the resistivity okay in between these two, then they are the good conductor of electricity. Insulators like rubber and glass have resistivity of the order, look here. The resistivity of glass or rubber have of the order 10 to the power 12 to 10 to the power 17 ohm meter. Look here how much big it is. The resistivity of insulators are in the range between 10 to the power 12 to 10 to the power 17. So both the resistance and the resistivity of a material vary with temperature. Yes, resistivity and resistance both vary with temperature. And how do they vary? With increase in temperature, the resistivity and the resistance both increases. And most important thing in this paragraph is the tungsten. Tungsten, okay, this is also known as wolfram. The Greek name is wolfram, tungsten, and the symbol of tungsten is W. It is W. It is W. Is used almost exclusively for filaments of electric bulb. You know the bulbs, the filament bulb. Nowadays it is not available, but okay, now it is available. In very rare cases it is available. Nowadays these LED bulbs are available more in number. So the filament bulbs, this tungsten is exclusively used for filamentous electric bulb, whereas copper and aluminium are generally used for electrical transmission wire. Okay, or electrical transmission line it is here. Which one? Copper and aluminium both are equally good. Among this copper and aluminium, copper is better than aluminium in two ways. One is that copper has more strength, and secondly, copper has less resistance. So energy in the form of heat, okay, is not lost when the current is passed or when current passes through copper. Look here, this is the table given here. So silver is the best conductor. Look here, its resistivity is 1.6 into 10 to the power minus 8 ohm meter. Okay, copper has a little more, then aluminium has still more. It is here, and here lastly look here, the diamond and this paper, dry paper, have very high resistance. Okay, so therefore they are the bad conductors. So these are insulators. So the resistivity of insulators are of the order 10 to the power 10 to 10 to the power, it is 14 given here now. It's okay, like this it is. Yes. So this is the resistivity of glass, this is the hard rubber, and this is ebonite, and this is diamond. Okay, paper. Now the next topic is resistance of a system of resistors. You know what is resistors? So resistors are conductors having appreciable amount of resistance. Okay, they are known as resistors. Okay, uh, wires have some resistance, so they are you can call them resistors, like tungsten wire, like nichrome wire. So they are the resistors. So these resistors, how to connect resistors in a series. So this is very important one here now. So the connection of resistors, okay, can be of three type. One is the series connection, other is parallel connection, and third is the mixed connection. Mixed means series and parallel both mixed it is. So just you can see here now in this figure. So this is a series connection and this is parallel connection. This is series, this is parallel. Look here, R1, R2, R3, three resistors are connected in series. Okay, here in this case now R1, R2, R3, they are connected in parallels. Okay, they are connected in parallels. So this is series connection, this is parallel connection. It's okay. And this is V for this is voltmeter, A is for ammeter, A is for ammeter, V is the voltmeter. Voltmeter, you know, always connected in parallel. This is voltmeter connected to parallel to this series of resistors, and here also the voltmeter you will find connected to series of resistors here like this. So this connection is called parallel connection and ammeter in the series. Okay, do you know one thing here why ammeters are connected in series? It is because they do have very less resistance. And why do voltmeters are connected in parallel? Because they do have very high resistance. Okay, therefore they will affect, if they are connected in series, they will affect the current of the series. That is why they are connected in parallel voltmeter. Now resistors in series, this I will make another video for this one, resistor in series and resistor in parallel. I will make another video for this, audio video for this. Okay, till here, and the next video I will just upload soon.